I'm about to put the calendar up here. Okay, while you're kind of getting your stuff out, look up here at this little calendar that I'm showing you. Okay, so today here we're doing related rates day 3. Okay, then on Friday, we're going to review for your next test, which will be on Tuesday next week. Okay, it'll be just like last time that you'll have a multiple choice part, and then you'll have a free response part. They'll be the same day though. Okay, then someone said, what about that test? That's just, this is not a test. It's called the first derivative test, but it's not a test that you're taking. That's just the name of the notes. So you're reviewing on Friday, testing on Tuesday. It'll count as 2 test grades. Good? And then if you don't have a calculator, will you get one? Go ahead, Leo. Okay, you have to have a calculator today. You do need a calculator. All right, and then if you will, skip ahead to your trig recap.
It's a miracle.
You guys just need a calculator?
Long time no see. But you're healed. I'm so happy. We're so worried about you. How would you describe it? Like,
Daniel, you need one? Woo. You need one? I have one. Yeah, you need one? All right.
I guess you just said that.
Okay, so listen up. Okay, we need to do just a few examples with angles. Okay, and then I'm going to make sure you're in total registration. If you're not, you guys should have time to kind of start on hopefully your test review early. So before we do that, we need to review trig. So do you remember SOHCAHTOA? Okay, let's put Chromebooks away for now, please. You'll have time to pull those out later if you need to work on something else. Okay, so what does SOHCAHTOA stand for? Let's start with SO. Okay, sine equals. Very good. Opposite over hypotenuse. Okay, and if you know that you'll remember what that stands for, you just put O over H. Okay, what does that stand for? Cosine equals adjacent over hypotenuse. And then TOA? Okay, tangent equals opposite over adjacent. Okay, a couple of just little notes here. Okay, when we are referring to the legs of the triangle, that does not include the hypotenuse. The hypotenuse is the angle across from the 90 degrees. Or sorry, I said that wrong. It's the side across from the 90 degrees. That means that in this case, the hypotenuse is this 13 side. Okay, the other 2 sides are both called the legs. Okay, and then depending on where you have your theta, will determine which leg is the adjacent and which leg is the opposite. So if my theta is here, okay, where it's drawn in, will 12 be the adjacent or the opposite leg? Okay, this is the adjacent leg. Okay, so adjacent means touching, so it would be touching where the theta is, which means this side is your opposite leg. Okay, from there, I want you to write all 6 trig functions. Okay, you should have done like a whole unit on this in pre-calc. So sine theta equals, cosine theta equals, tan theta equals. Okay, your remaining 3 trig functions are the reciprocal IDs. So cosecant theta, secant theta, and cotan theta. Okay. Prior to us starting to find sine, cosine, tangent, blah, 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 you really need all 3 sides of the triangle. So I see that I know the adjacent, I know the hypotenuse, but I do not know the opposite. Okay, what will allow me to find this 3rd side if I know the other 2? Pythagorean theorem. Now, can I do 12 squared plus 13 squared? No. Yes? Yeah, they're right there, kind of behind that little curve. So I'm going to call this x for now, just since we don't know what it is. So it'd be 12 squared plus x squared equals 13 squared. Okay, then in your calculator, I want you to just minus the 12 squared across. Okay, you can find both of those numbers separately, but remember that the AP exam is time. So whatever saves you time, you should do it. So in your calculator, type in 13 squared, take away 12 squared. Okay, and then that would equal x squared. Then do what? Square root is going to give us 5. Very good. So x squared is 25, which means that the missing side is 5. Okay, from here, sine theta, okay, the ratios that you have up here at the top, they allow you to find the values of sine, cosine, and tangent without actually knowing how big the angle is. So for example, I don't know how many degrees is in theta, but I know that whatever theta is, sine will equal the opposite divided by the hypotenuse. Opposite would be 5, hypotenuse would be 13. So put 5 over 13. Okay, then you should also know that sine and cosecant are reciprocals of each other. So if sine is 5 over 13, what would CSC be? 13 over 5. Very good. Okay, let's go down to the next one for cosine. Even though I don't know how big theta is, I know that cosine theta is going to equal the adjacent side divided by the hypotenuse. What fraction would that be here? 12 over 13. Which would mean that secant would equal the reciprocal of that, or 13 over 12. Okay, last one like that for tangent. Tangent is TOA, or opposite over adjacent. So my opposite side would be 5, my adjacent would be 12. Okay, then also keep in mind cotan is the reciprocal of tangent. So instead of 5 over 12, it'd be 12 over 5. Okay, do we feel like we can do this? All right, let's make it calculus-y. Okay, go to the next one. We're going to have to draw a little picture here. It says a fish is reeled in at a rate of 2 feet per second from a bridge that is 16 feet above the water. So draw yourself a little bridge here. Okay, here's the water. Here's the fish. And then you have a guy up here, okay, who's fishing the fish. Okay, just do your best. Okay, and then I think I've told y'all this, but usually for the AP test, if it's something like this, they give you a picture. Okay, Most important part of this process is you determining what is a fixed constant and what is varied. So if my guy is fishing, is the length away on his rod a constant or a variable? Variable, because as he reels the fish in, what's going to happen to this distance? It's going to shorten. So we're going to call it L for fishing line. Okay, next variable, how high the guy is off the ground. Is that a constant or a variable? Constant. So I'm going to label the height of the bridge with how tall it is. How tall is it? Okay, the bridge is 16 feet. That's this side here. Okay, the third side is how far away the fish is from the bridge. Is that a constant distance or a changing distance? So as you reel him in, he's going to get closer, right? Until you eventually pull him up. So we're going to just call this X. Okay, so now that we kind of have our setup, let's do our find, given, when, and our equation, just like we were doing last week. So find, given, when, and our equation. Okay, let's read back through the question and try to fill in whatever we can. It says a fish is reeled in at a rate of 2 feet per second. What is that? That would be DLDT. And what category would that go under? Given is correct. So DLDT equals 2. True or false? -2. Okay, and then feet per second, sure, we can add that as well. Okay, but why is it negative? Because the amount of feet in the fishing line is decreasing as he reels it in. Okay, then it says, at what rate is the angle between the line and the water changing? Do I put my theta here or here? 1 or 2? 2, put your theta here. And then I'm finding how fast that theta is changing. I would call it d theta. So it says, at what rate is the angle between the line and the water changing when there are 20 feet of line out? That means that my line needs to equal 20 feet. Okay, from here, your equation is going to come from you picking either so, pa, or toa. Okay, but you want to pick the sides that you know stuff about. So if this is my theta, what would 16 be labeled as? The hypotenuse, the opposite, or the adjacent? Okay, this is the opposite. And then what would the L be?
Hypotenuse.
Okay, then that means that X is my adjacent. Okay, now remember, you want to pick so, ka, or toa that has stuff in it that you want to know about or that you already know about. So I already know the 16. I want the L. Then that means I want these two sides in the same trig. Who am I picking? So, ka, or toa? Sine is opposite over hypotenuse. So it'd be sine theta equals. My opposite side is 16 over my hypotenuse side is L. Okay, that is the equation that we're going to then be taking. Now, before you take the derivative, this is written as a fraction, which means I'm going to have to do quotient rule unless I can rewrite it. What property would allow me to take the L from the bottom and just move it up? What would I have to do? Negative exponent. Very good. So I'm going to put right here, rewrite sine theta equals 16L to the negative. And that will allow me to not have to do quotient rule so that I can just do regular power rule. Okay, come up here to the top. Let's take the derivative. What will the derivative of sine theta be? Sine theta is going to go to cosine theta. But then because it's a theta, do you remember we have to put a d theta dt behind it? Okay, now on your other side, it was a 16L to the minus 1. We want to take the derivative. So the negative 1 is going to times down. What's in the front now? Negative 16L to the what? Negative 2 and then DL. Very good. Okay, so my negative 1 times is down. I take away one more. That gives me the negative 2, then the DLB. Now, before I plug stuff in, I'm going to take my L to the negative 2. I'm just going to drop it back into the bottom. So I'm going to have cosine theta d theta dt equals negative 16 over L squared DL. Okay, but hopefully we can recognize these are really the same thing. But with negative exponents, if you're trying to plug a number in, just put it back into the bottom. All right, let's plug stuff in. What is my L? How much fishing line is out? So negative 16 over 20 squared. And then we know dl dt. What's dl dt?
-2.
Negative 2. Okay, now let's come back over to this side. D theta dt is what I'm looking for. Okay, so it really shouldn't bug you that you don't know d theta dt because that's what we're trying to find. Okay, for the cosine, you're going to have to use a ratio of the sides from the triangle. So sine is O over H. What is cosine going to be replaced with? A over H. Now look back at your little triangle. Do we know both the A and the H to be able to plug in for that? Okay, we don't know but if we know that this is 16 and we know that this is 20, can we find the third side to plug in for A over H? So you're going to do that in your calculator. So we're going to have to go back to find the adjacent side. So if my L is a 20 and this is a 16 and that's an X, I'll do X squared plus 16 squared equals 20 squared. Okay, then in your calculator, do 20 squared take away 16 squared. What's that going to give us? 144, and then take the square root. So my X side is 12. And now that I know that this side is 12, when I want to substitute my cosine, I'm going to use A over H, which would be 12 over 20. Okay, 12 over 20. Okay, last thing, we just need to solve. So if my 12 over 20 is multiplied by d theta dt, how are we going to get rid of a multiply by 12 over 20? Very good. So if I want to get rid of the 12 over 20, I'm going to divide by 12 on both sides. And I'm going to multiply by 20 on both sides. Okay, so a lot of teachers will say to get rid of a fraction, you're just going to multiply its reciprocal on both sides. So that'll cross out your 20s and your 12s at the same time. So then you have d theta dt equals, and then we're just going to put this into the calculator. Okay, make sure that you use pretty fractions when you do it. Otherwise, you may end up with typing it in wrong. So we want negative 16 over 20 squared multiplied by negative 2 multiplied by 20 over 12. Okay, just like that. Okay, then when you are measuring d theta dt, your units for an angle, a lot of times they do not use degrees on the AP test, they'll use radians. So it would be radians per second. Now, quick question. Is my angle going to be an increasing value or a decreasing value? Which one? What'd you say? Increasing is correct, because how did this come out? Positive. Okay, so I want you to think about, okay, pretend, look back at the picture. Let's pretend like we reeled the fish in to here. Can you kind of envision that as the fish gets closer, this angle is going to start getting fatter as it kind of closes in? You kind of visualize that? That as this pinches in, it's going to have to widen until eventually the line's going to be straight up and down and be a 90-degree angle. So let's just write a little sentence for that. At the instant when there is 20 feet of line out, the angle is growing 2 radians every 15 seconds. Okay, and then just kind of see if that makes sense. Or you could put 2/15 radians per second if you like that. Okay, but it's 2 radians every 15 seconds. We know it's growing because it was a positive value. Make sense? Okay. All right, go ahead and turn ahead for me, please, to let's just do the next one, it's fine. 2. We only have to do 3 more. I don't know if that, they kind of take long, but it's okay. So next one. Okay, we have the top of a ladder sliding down a vertical wall at a constant rate of 3 feet per minute. Draw the wall. Draw the ladder. Okay, first thing that's most important is if it is a fixed constant, you give it a number. If it's a variable, you need to pick a letter. So read through your problem and I want you to decide what the fixed constant is. Okay, the top of a 25-foot ladder is sliding down a wall at 3 feet per minute. What is not changing? How long the ladder is. How long is it? Then I can put a 25 here. And I don't have to pick like L for ladder because that's a fixed distance. Okay, however, how far away the ladder hits on the ground, that's a variable. So I'm going to call it X. Okay, then on this side, I'll call it Y. Okay, the top of the ladder is sliding down the wall. All right, find given when. Go ahead and try to read through that and fill in maybe a couple parts of that. So top of a 25-foot ladder is sliding down a vertical wall at a constant rate of 3 feet per minute. What did they give you? dx dt or dy dt? dx dt is the base of the ladder, so it'd have to be dy dt. Now, one more question. Should the dy dt equal 3 or -3? Should be negative because as the ladder slides down the wall, this distance is going to be shortening. Okay, so that should make sense. Then it says right here, when the top of the ladder is 7, is that an X or a Y? Y. So when Y is 7, what is the rate of change of the distance between the bottom of the ladder and the wall? What are we finding the rate of? We already know dy dt. The bottom of the ladder to the wall is what? Dx. Okay, this part you should be able to do mostly by yourself. What equation will you use to relate x, y, and 25? We just used it. Not sine or cosine, because you're not doing a theta yet. 3 sides of a triangle. A squared plus B squared equals C squared, or in this case, X squared plus Y squared is. Okay, so complete part A, because we need that to do part B, which is where the trig comes in. Okay, so you're gonna take the derivative of that and then plug in your pieces. Okay, you should get a fraction of your answer. Let's see if you can do it. You can do it. Yes. Sure. Now you can okay. All right, we're in that piece one. Let's turn that page. Y'all, what's the derivative of 25 squared? 0, because it's a constant. Okay. So, and what you need here is dx dt and dy dt. You take the derivative of x's and y's. Yeah. Yeah, that's right. And now you just need to plug your stuff in, and you're going to be missing a side of the triangle that you'll have to go back and find. That's right. Good. Oh, your ladder looks so good. Yeah, you did them like all perfectly parallel. I guess it's supposed to be. Okay. Your ladder looks. Now it does look a little wobbly, like you guys definitely vibrant. That's what I'm saying.
Well, it's already sliding down, so.
That's true. That's
It's
make sure when you do the derivative of x squared, that's correct. And then 2y. They remember and then since you are gonna end up being missing the x, you have to go back to the so if you know the y is 7, and then he was like, oh, I got the x you know what that is? Yeah, it's like y is fine. And you'll plug it in right everything except for your
It's the real like with that man. You don't understand how bad it's like.
It's like 44 pounds.
Yeah, now let's plug some in. Okay, no, you did it. Now, so do you notice that they when we're trying to find x, we only have enough. But remember, it's a triangle, and I'm like, why is this so good? Like, so I can find x. So you'll do a little side Pythagorean theorem. Yeah. 576. Oh no. Okay, so now you know, add it to your ones, then that's what's gonna be. And then now you can plug into here, the XT is what you're trying to talk about.
Yeah.
Well, let's plug stuff in. Now, you'll notice that your X, we don't have that, right? But if we know that our Y is a 7, and this is 25, can we find the X that goes with that? You're just doing a little Pythagoras on the side. So the X squared plus 7 squared equals square root of 5 squared. So that you'll know what to put in this X spot. Okay, that's right. Just replace it by
This guy makes that sound.
Yes, sir.
That's what it's supposed to be. I know what it's like now, but you know, it's. I don't know how you're going to that thing, what's in by.
So it should have been.
I know. I didn't get that experience. I went back.
But it looks like other than that. So just adjust your numbers in there.
It doesn't have.
Okay.
It looks like a.
Good.
Yeah, what's called the same.
Yes.
Like life.
As soon as they are having.
Very nice.
And then you're gonna add that number across. Remember, we're doing I think you have a lot of stuff in your.
I can't remember.
Numbers, how you're.
They have like a few.
No, two parentheses X, what's your X? Just that big. And that's what you're looking at. Hold on, your Y, 7.
I got 20.
And now just plug in and get your DXTV along. This looks great. What do you think? I believe that's vaccine should be 42. And keep it as a fraction. No guesses, Abdullah. No need to guess.
Right now.
Yeah.
That is actually pretty wild. Good job. Sure. Uh-huh.
Yeah, it is. God, 708. That's not right.
It should be 7/8. Yeah, that's right. All right. Okay, for your answer. All right, let's bring it back together. You should have gotten 7/8. Okay, 7/8. So let's go down to part B now. This is where the new stuff comes in. Okay, it says find the rate. Find the rate at which the angle formed by the top of the ladder and the wall. So put your theta in your picture in the corner that's touching the top of the ladder and the wall. No, this is not possible. So for our find, we're gonna find d theta dt, where our theta is this top corner up here. Okay, then really you don't have any new givens, but you are gonna need a new equation. So let's write equation right here. I'm gonna skip the given and the when because that's all the same. Okay, if I pick tangent. Okay, let's just start with tangents. We have 3 choices. My tan theta would equal which two sides?
Well, X over one.
Okay, good. So I want you to write down tan theta equals. It's opposite over adjacent. Opposite would be my X side, and adjacent would be my Y side. So it'd be X over Y. Now, let's decide if we want to use this equation. Okay, when I take the derivative of tangent is secant squared. Kind of weird, but it's fine. Okay, but what am I going to have to use on X divide Y? What rule? Quotient rule. If you cannot use quotient rule, you should always pick that. So I'm going to put here, this needs quotient rule. And then I'm going to put nope and move along. Okay, TOA is not going to be the one that I want if I'm going to have to do quotient rule. Now, if I don't have another option, then fine. But let's now think about our other ones. Let's try sine theta. Okay, for sine, what would my theta equal?
25.
Opposite is X over 25. Will that need quotient rule? No, then that's going to be great. Let's do it. Now, the way that it's written, it looks like it does need quotient rule. So I'm going to still rewrite it. But will I need to use a negative on my X? If it's already on the top?
No.
No, I'm just going to pull the 1 over 25 to the front. So that now it's clear that this is just a number in front of an X. Okay, this is a regular power rule. So let's take the derivative. What is the derivative of sine theta? Cosine theta what? D theta dt. Very good, Linus. That's right. Okay, then on the other side, it's a number times X. What's the derivative going to be? 1 over 25, and then times what? Dx dt. Now, why doesn't the X stay? Because when I power it down, regular X would drop off to an X to the 0, which means it's gone. Okay, so there's your derivative. What will I plug in for cosine theta? What side ratio? So, ka, or toa? Ka is A over H, so look back at your circle. What was my A? X was, oh wait, sorry. A is, Y was 7, you're right. Over, what's my H? 25. So my cosine is 7 over 25. D theta dt is what I'm solving for. 1 over 25, and then my dx dt is this number that I just found. Remember, we got 7 over 8. Okay, then from there, how do I solve for d theta dt if I have a fraction in front? Yeah, so divide by the fraction, which means multiply by its reciprocal on both sides. So I'm going to put a 25 over 7 and a 25 over 7. You should not need a calculator for this one because a lot of stuff crosses out. D theta dt equals. What are the two numbers that are going to cross out? The 25s and the 7s. That's going to leave you with 1 over 8. What are my units for a rate of change of an angle? Radians per. Now, in this case, we were measuring in minutes to be radians per minute. Okay, now think about for a second. Go back to your picture. If I'm looking at my little ladder, pretend my pen is the ladder, okay, and the ladder's falling, what's going to happen to the angle between, pretend my hand is the wall, this is the ladder. As it falls, what's happening to that angle? Is it getting bigger or smaller? Bigger. Look, as it's really high, it's a little tiny angle. And then as it slides out, that angle is getting bigger. My hand's the wall. Yeah, then that means a positive rate of change would be what we expect. Good? Okay. We have to do only one more. Turn for me, please, to the next trig recap. Okay. So it says find, yes? Yes?
I was gonna ask my.
Yeah, sure. Go ahead. Okay, so it says find the hypotenuse of the triangle, but it should also give you an angle for theta. So let's say that theta equals 20. No, that's an obtuse angle. Let's make it 172 degrees.
I thought opportunity bigger.
I know I said the wrong thing. It's still fat, but it's not. Okay, so let's say that you're given that this theta is 72, and the question asks you to find the hypotenuse. This is more pre-cal that you should know. Okay, but it's okay that it's been a while. So if this is a 72-degree angle, I want you to think about which side is 6. Is it the opposite, the adjacent, or the hypotenuse? This is the adjacent, which means that if I'm looking for the hypotenuse, do I want to start with so, ha, or toa if I want this and this to be in the same equation? Okay, so write down on your thing, you want the cosine of 72 to equal adjacent over hypotenuse would be, let's do 6 over c. And I'm going to do c just for like, that it's like ABC on the triangle. Yes. Okay. From here, here's how you're going to solve. Okay. Take your cosine 72, put it over 1, and you're going to cross multiply. So cosine 72 times c is cosine 72 times c. 1 times 6 is 6. And then how would I solve for side c? What would I need to still do? Divide cosine 72 on both sides. And then whatever this divides to is going to tell me how long side C is. Now, before you do that, make sure that you're in degree mode. So in your calculator, hit mode right here. Okay, you need your degree to be highlighted or it's going to give you a different answer. Okay, and then we'll do 6 divide cosine 72. So we got 19.416. Okay, so before we go into the next question, I want to make sure that y'all are solid on what trig does. Trig gives you a connection between the angle in a triangle and its sides. So if you know only one side, but you know the angle, that's enough information for you to find both of the other two sides as well. Pythagorean theorem, how many sides do you have to already have? 2. But if you have an angle, then it's okay if you even only have one side. So let's do question number 17, and then we'll be done with your notes for today. Okay, so it says the angle of elevation of the sun is decreasing at a rate of 0.25 radians per hour. How fast is the shadow cast by a 400-foot building changing when the angle of elevation of the sun is pi 6? Okay, on your picture here, angle of elevation is the measurement from perfectly horizontal up to look at the sun. That would be your theta. Okay, read through the question one more time and tell me my one fixed constant. What is not changing in the picture? Okay, the building is 400 feet tall. That is correct. Okay, then I want to know how fast the shadow is changing, but the sun's position is going to affect how long the shadow is. So I'm going to call this X. Okay, just because it's horizontal. Okay, then for this third side, I'm just going to call it C since it's the hypotenuse. So now what I want you to do is your find, your given, your when, and your equation. Your find, your given, your when, and your equation. So the question says, how fast is the shadow of the building changing? What would we call that given how we've labeled our picture? The what? Which one's the shadow? X is the shadow. So I would find dx dt. Okay, what angle was I given? How fast what is changing? The angle of elevation, which would be my theta. So d theta dt. And then it says it's equal to 0.25. If you want to put radians per hour, you can. Is that correct? Negative. It says it's decreasing at a rate. Okay, so rather than the sun going up, we know the sun's going down. Okay, then it says how fast, blah, 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 when the angle of elevation of the sun is pi 6. That means that theta needs to be pi over 6. Now, before we continue with the question, put your calculator back into radian mode. Okay, 9 times out of 10, AP, you're going to be doing radians, not degrees. So you're going to hit mode here and then just go down to radians. Okay, so look at your equation or your picture. Do I want SO, PA, or TOA? If this is my theta, I always want a fixed constant, and I'm trying to find the x dt. TOA is correct. So write down tan theta equals. Remember for tan, it's going to be opposite over adjacent. My opposite is my 400. My adjacent is my x. Notice I cannot plug in any numbers besides fixed constants until after I've taken the derivative. What rewrite will I need to do before I take the derivative? My x is on the bottom. Hate that. Negative for the x. So it'll be 400x to the minus 1, and then we'll take the derivative. Okay, for tangent. Anybody remember the derivative for tangent? Tangent is going to be secant squared. Close. And then when I take the derivative of tangent, I get secant squared theta what? D theta dt. Very good. Okay, then on the other side, I'm taking the derivative of 400x to the negative 1. So my negative 1 is going to times down and give me what? Negative 400x to the what? Negative 2 times dx dt. Very good. Okay, then from there, before I plug any numbers in, if I have a negative exponent, I'm just going to push it back down to the bottom. Okay, you can do this step in your head if you want, but since it's your notes, I'm going to write it. So secant squared theta, d theta dt equals. This is a negative 400 over x squared dx dt. Okay, from here, the only thing that I should not know is dx dt. Everything else I should be able to find. Okay, instead of me using SOHCAHTOA for my secant squared, I know what theta is this time. What is theta? So I'm just going to plug in pi over 6 and then get that answer. Does that make sense? Okay, so which one's your pi over 6 finger? Been a while. Would you? 0, pi 6. Hold it down. Secant is cosine. Secant is cosine flipped. How many cosine fingers do you have? Root 3 over 2. Then what would that be if I flip it? 2 over root 3. So let me write this down. This is going to be the cosine of pi 6 flipped. Okay, so secant and cosine are reciprocals. So pi 6 is here. I get root 3 over 2. But then to flip it, I'm going to put 2 over root 3. Now, keep in mind that once I find secant, I still need to do what to it? Square it. D theta dt. equals negative 400. And then when I get to x, do we know x? So we're going to have to just leave it for a minute. And then we do know, oh wait, we did know d theta dt. What was it?
Oh, negative.
Negative 0.25, sorry. And then this is the one that we're trying to find. Okay. So it's this times this equals negative 400 over something squared equal to dx dt. Let's clean this side up before we keep going since I messed it up. What is 2 squared on top? What is root 3 squared on bottom? 3. And then I'm going to times that by, what is 0.25 the same as? Negative 1/4. How is that side going to clean up then? It'll just be negative 1/3. Okay, so think about that for a second. When I square this, I get 4 over 3. 0.25 is 1/4, and then those 4s are going to cross out. All right, now let's come back to here. We still need to know x. Okay, so if I know that my theta is pi over 6, then I can solve that right here. So do a little side problem. We know that tan of pi 6 needs to equal 400 over x. And then I'm just going to put it over 1 and cross multiply, just like we did in your little example. So in your calculator, find the tan of pi 6. What'd you get? 0.577x equals, what's 1 times 400? 400. And then what do we do with the 0.577 to solve for x? Divide it. So I had the x equals 400 divided by that answer that we just had. And we get 692.8. 692.82. Okay. And then that's the number we're going to put right here. So it'd be negative 400 over 692.820 squared. Okay, then last question. If I'm trying to get rid of this fraction in front of the dx dt, how do I do it? Multiply by its reciprocal. Very good. So to get rid of the negative 400 over 692 squared, I'm going to multiply both sides by 692 squared over negative 400. Okay, to cross that out. And you can just do that part in the back. So 692.820 squared over negative 400. And then from there, I know my negatives are going to cross out, so my answer should come out positive. Okay, you want to do your pretty fraction? We're going to copy the 692 number and square it. We're going to divide it by negative 400. We're going to times it by negative 1/3. Just like that. Okay, and we get 400 as our final answer. Now, dx dt is measuring a shadow. So what would its units be measured in? Feet per hour is the time for this one. Okay. Most of the angle questions you see, though, are going to be the first type, not this type. Okie dokie. All right, so here's the plan. You do not have a new homework. Okay, I'm just going to give you your test review and let you get started on it. You have about 30 minutes today plus all of class next time. And then your test will be on Tuesday. Okay, Annie.
Apparently, it's not. I mean, I'm on three. Oh, I see that. No, not. Well, I just didn't. We're watching a Twitter video. Yes, I did feel like. As there's. It's just like.
Yeah,
No.
I think the back of that last page is for you.
I would say drive through. Yes, you want it, like. We read the list, and there. We don't actually, but at least five. No,
Okay, real quick before you get started, can I tell you which ones we're going to do next class so that you don't waste time doing them? Okay, turn to your related rate section or the back 2 pages. Okay, and I'm going to tell you the hard ones that we're going to do together. Okay, we'll do number 15. Oh, it's frozen. Okay, we'll do this number 15. Find it. I didn't number it. Sorry. It's like it jumps all over the place.
Okay.
Okay, so find this one. Now you probably can do 15. It's pretty similar to the 2 formulas at the end of last time's homework. But this one, turn the page, the railroad track. Okay, we'll do that one together. Notice it's a part A and a part B. So don't feel like you need to do either one of those. We'll do those next time. Okay, it's 14 with a little star. And then the last question that I know we're going to do together is the last page. Okay. The reason the numbers jump around is I pulled them off of AP tests and I just didn't bother to read them. Okay. So you have the rest of class to work on that. Listen, okay, we don't always have time to number things.